in these acts as adults. However, if you compare the reaction time, yes, the adults press the response buttons at around 600 milliseconds time. Children press it at 900. So look at the proportions. This visual processing is not much slower in children than in adults. However, the speed of responding is radically much longer in children. So there is something beyond the visual processing which slows them down. And this huge difference here fits very nicely with this very large discrepancy between resolving the motor responses. Yes? So that's like why we conclude how we concluded. That seemingly the visual analysis of these pictures, the visual analysis of the mental images basically takes about the same time or a little bit longer in children than adults, but what takes radically longer is pressing the response button and resolving this conflict here in terms of the responses, in terms of their actual hands, so to say. And that's the implication what we discussed for the testing of children, let's say. If you just test them like this and you find that their performance is lower, they are slower, they commit more mistakes, whatever, you may conclude that this difference arises because they can't cope with this mental image processing, so to say. They can't cope with the cognitive demands of the task. But in this case, actually, it seems more likely that they cope with the cognitive demands quite well. What they can't cope with efficiently is the responding in this task. So it gives you an additional, quite a lot of additional information about this task. What's the source of error? What's the source of performance inefficiency in these children? Okay, these are like 7, 8, 9-year-olds. So we are talking about early primary school, but it makes sense that in this age, I mean, this fits those observations, you know, when perhaps often children suddenly look unexpectedly clever. They understand lots of stuff which you may not expect, but they may not be able to express that kind of understanding. I think this fits these observations relatively nicely. And they can surprise you, but they can never get to the point when they can actually express their knowledge. Or if you put them under time demands even more, it may not mean that you are validly testing their cognitive capabilities. You may be more testing their motor response capabilities. How quickly they can write, this comes up in a test as well. They may be able to think at high speed, but if they write slowly, you are not really testing what you want. You are testing writing speed instead of cognitive ability. And this may be quite, let's say probably the cleverer is a child, or the larger is the dissociation between the two, the more disturbing it is for the child. And like this writing skill must be poor for various reasons. I mean, that's one issue of dyslexia, for example, confusion at certain levels, or if you want to test mathematics, let's say, but the child is an experienced writer or reader, they may be able to cope with the math demands, but they may not be able to cope with actually expressing the response at the right level, or just being really confused and writing it down, or reading it out. So that's why I wanted to get. I would have wanted you to discover the yeah, I think it's a very interesting thing. And this is like one example, I think, where these dissociations and this dissociation cannot be discovered without a neuroscience method. Because if you just have behavior, or you see slow responding, lots of errors in children relative to adults. But you don't know whether this is because they are cognitively weak. And that's actually the first assumption. Yes, that would be the first assumption, that this task is too difficult for them. But you don't really know why. And you can't even tell for sure. But if you look into their minds, literally, basically literally, with this method, is it mentally which you're responding, to use this phenomenal description, then you can conclude the slow solution times have nothing to do with cognitive understanding. They have to do with response organization, which is a different skill. Usually it's not what you want to test.
What about functional MRI imaging data?
In this case, what do you think?
I
Would
think
it be
the children, maybe the processing may be going through many different paths, so it takes a longer time to get to the points.
That is an excellent comment. That, for example, the implicit comment here is that you could use functional MRI to detect, let's say, how many brain regions are active. Maybe in children, this requires much more coordination, most probably, at the level of response organization. Yes? But on the other hand, if you think about the poor time resolution of functional MRI, for example, in this case, you couldn't use functional MRI to distinguish between any of these speed differences between the two groups. You could look at anatomy, but you could say nothing about timing. So for timing question, that wouldn't be the right technique to use. It's a very good example from that side as well.
It's very interesting to know what's happening in the brain from the incoherence from the lower level from the higher. So what's happening in the brain? Talking about for the lowest part, for the bottom of the red line to the highest. What is happening? Yes. This is a very dramatic change. If we had a functional MRI, we really know they see the kids, the adults, the other parts of their brain to help them to solve, to cope with this different tasks.
Yes, that's how it could be used. You wouldn't have timing information, but you would see the anatomical matters. So it may be useful.
So I'm thinking if we know what part of brain they use to solve this problem is for education. We know that for education implication, we know how the intervention, if it's sensory or motor or other kind of parts of the brain can help the subjects to solve the problem.
What would be your recommendation?
I'm thinking, if I do this experiment, I'm trying to see how if one of the children, they just conduct the experiment like that. Another one, before they start examination, I will tell them, explain to them, in fact, we are going to conduct an experiment. But you know that in the real world, we can see the phase defined is bigger. We can use the actual size we see. And or we can use real-life experience to judge. You know, because it's testing where they perceive the things according to the science or what they see the pictures. And other level is in real world. That will we have to solve this conflict. If we tell the students before they do the examination, I wonder what's the difference. Is it the same? If we already tell them how to solve this conflict, and it be more effective to them to find the way or with the performance.
Well, it may have some effect, but probably what would have a real larger effect is practice, I guess, because you can train this kind of conflict resolution. So it's difficult just to improve it by explanation, like nearly anything else. It's like exercise. Yes? So what would happen if you train these children for like 2 hours in resolving similar conflict situations? They may go crazy or very frustrated for a while, but it's kind of practice for them.
When I was thinking about for education, for the kids, it seems that they learn, they copy according to their automatically, they learn from different trials. Then should we get the restriction that even though I see the picture, the size is different, but in real world, they're not exactly the same. So I have to answer, get the right answer is, what is the size bigger in the real world? So if for the kids they are weak, I'm thinking for education, if we explicitly teach them the implicit rules and some rules for the grammar or for a solving the math, maybe we can enhance the ability in coding. That's why I'm thinking, is it we can teach the implicit rule expressly can be an indication for education.
Yeah. Well, probably.
So that just brings it up.
Yeah. Yeah. No.
I was actually sort of going to just talk something that you question just asked, and that's, I remember 10, 12 years ago when I first entered teaching, and one of the exercises we were shown to help children with dyslexia was exactly that. We'd flash up a word, it would be in a certain colour and they'd have to respond, or it'd be a left arm, right movement, like but they had to make that same decision. I'm not sure how effective it ever was, but it was fun and they seemed to enjoy it. So it's sort of in educational terms, it's been around for quite a long time, this incongruent and congruent tasks to try and train the brains. It's always sort of been in existence for a long time. Then your second point that you said about the like training them to a certain like a quick response answer is also a very complex issue, because when you're training them to try and get an answer quickly, but that's basically relying on some kind of memorization and things. That has a huge number of implications to their actual learning and the effectiveness of their learning as well. So it's just sort of interesting. But yes, it's funny because it's been around for a long time.
Yeah,
but how effective it is, I'm not sure there's any studies out there that have said training every day with this really works. Well, I'm sure there are some out there. Yeah.
It's basically delivering some kind of empirical evidence for or against something. Yes, because like most of these methods have been used in education since ages. But then some people argue like this, some people argue like that. So one objective of research like this would be to kind of deliver a verdict on what's right. And like without the neuroscience methods in this case, you simply can't tell. Because you just can have ideas, but whether you are improving cognition and improving responding is difficult to tell, because you don't have direct access to any of them. You have to, so to say, look into the brain to be able to tell them apart. And it's still not perfect how we do it, but definitely we can do something already about it.
So I think we had a very good fruitful discussion this morning. So to say this week's effort for this morning. So we will have a lunch break here, and then we will have the afternoon session for those who join us in the afternoon at 2:30 here as well. Okay, so thank you so much. So Jane, do you have anything?
I don't have any announcement, but please, we welcome for your comments. So in your folder, we have evaluation form. You can complete it and return it to me at your convenience. So we can go for lunch from 12 to 2:30, and the next workshop will be started at 2:30 at this room. Yeah. Thank you very much.
And just I note that this was the technical part, and the afternoon is about the math part. so that you know.